All right, chemistry and honors chemistry. This is the answers video for the day 2 assignment on math for chemistry. So I'm going to run through some, but not all of these, but enough that you should have examples. So I want to see you do the ones that are not done on this video or in class. Be sure to do the whole assignment for credit. Okay, so here we go. So we're going to add and subtract fractions. So use the crossing arrows method. So the 3 comes over here and goes on top and bottom. Okay, 3 over 3 equals 1, so 1 times 1/2 is still going to equal 1/2. But when we multiply it out, it actually comes in the form of, this in parentheses, 3 over 2 times 3 is 6. Now we bring the 2 over here. We put a 2 on top, a 2 on bottom. So if you don't understand the whole theory, that's okay. Just understand how to do it. 3 times 2 is 6, and 2 times 2 is 4. So we can come over here. So what we have is 4 over 6 here and the 3 over 6 here. So what you have is a common denominator. You need that number on the bottom. Okay, so 4 plus 3 equals 7, and you don't change the denominator, the 6, so there it goes. Okay, subtraction is done the same way. So we're going to come over here, put a 5 up here and a 5 on the bottom. Come over here. 3 over 3. So 3 times 3 is 9. 3 times 5 is 15. Minus 1 times 5 is 5. And 3 times 5 is 15. Okay, 9 minus 5 equals 4, and the 15 does not change. Okay, so that is your answer right there. All right, you do these two. We're going to move on to multiplication. Multiplication is numerator, the top, straight across, denominator, the bottom. When you draw these arrows here and here, it helps you to remember the process. So go ahead and do that the first few times. So 2 times 4 is 8. 3 times 5 is 15. You can't reduce that fraction, so that is your answer. Okay, down here. Now what we're going to do and what you should do is reduce before you multiply. Alright, so you can reduce across a time sign. In other words, you can reduce 2 and 16 the same way as if they were one right over the other. 2 over 16, which you could reduce down to 1 over 8. Okay, so we're going to do that here. 2 goes into 2 one time. 2 goes into 16 8 times. 9 does not go into 15, but they have what's called a common factor, 3. 3 goes into both of them. So 3 goes into 9 3 times, 3 goes into 15 5 times. Now again, you multiply straight across, top and bottom. 5 times 1 is 5, and 8 times 3 is 24, and that's your answer. If we had not reduced, you would have had 15 times 2 is 30, and 16 times 9 is 144. 30 over 144. You would have had to reduce that down. That's kind of messy because those are kind of big numbers. But you would have ended up finally with 5 over 24. So it's best to do the reducing before you multiply. All right, keep going. All right, I only gave you one of these, so I tell you what, I'm going to give you one down here as an example, and I want you to do this one. There is one on the video as an example as well. So I'm going to do this one, 2/3 divided by 5, let's do 5/8. Okay, so I'm giving you example, then you do this one. Okay, so what you do is you take the bottom and you flip it. You don't do anything to the top. Leave that alone. So it's 2/3 times the bottom flipped over, 8 over 5. Okay? There's nothing here that I can cancel, so I'm just going to multiply straight across just like we did up above. So 2 times 8 is 16. 3 times 5 is 15. When the top is bigger than the bottom, that's called an improper fraction. As far as I'm concerned, you can leave it as an improper fraction here, okay? So that would be your answer. So again, leave the top alone. Some of you have heard the expression, keep change flip. Anyway, leave the top alone, flip the bottom, and multiply, okay? All right, now, in this situation, you have a whole number and a fraction. You turn the whole number into a fraction, so it's one additional step. We're going to turn that into a fraction by making it 6 over 1, so now it's a fraction. And then we're going to leave this fraction like this initially, right away. Okay, so first do that step. Now I'm going to come down and I'm going to do what we did over here. 6 over 1 times this flipped over. 4 over 3. Okay. There is an opportunity to cancel. 3 goes into 3 once. 3 goes into 6 2 times. So 2 times 4 is 8. 1 times 1 is 1. And of course you don't leave it as 8 over 1. It's just 8. Okay. This one you do the same thing. You're going to put a 1 underneath the 3. 3 over 1. And then you do the same process. Flip and multiply. Okay. All right. Let's keep going. Okay, this is changing from an improper to a mixed fraction. So a mixed fraction has a whole number part and a fraction part. So the way you do this, you got to know how to do a mini division. If you don't know how to do division, I'm going to teach you. All right, so it's 2 divided into 7. That's really what a fraction means. It means this number divided into this number. So 2 goes into 7 how many times? It goes in 3 times. Then the next step is you multiply. 2 times 3 is 6. Then you subtract. 7 minus 6 is 1. And you're done. You have a remainder of 1. So the way you write it is this is the whole number part. This is the top of the fraction. The remainder is the top of the fraction. And the divisor is the bottom of the fraction. So that's going to be 3 1/2. Okay, so you just got to keep straight what order where these things all go. Okay, so you go ahead and do that one. Now we're going in the other direction. So this is the around the world method. So you multiply the 5 and the 2. Whatever you get there, you add that to the 4. And then you place all of that over this 5 here. So you go all the way around the world there. So let's do that. So 5 times 2 plus 4. 5 times 2 plus 4. All of that over 5. 5 times 2 is 10 plus 4 is 14 over 5. And again, it's an improper fraction, but that's fine. You can leave it that way. Here's the thing about, if you're going to do further math, if this is an intermediate step in some sort of a math or science problem, you need to work with this as either a proper or an improper fraction. This 2 4/5, you can't multiply that. You can't, for example, say 2 4/5 times 4. If you got to do further math on this, you can't do that. You can't work with that. You'd have to convert it into this. Make it 14/5 times 4. And now you know how to multiply fractions. You could go ahead and do that. Okay? Alright, so that's why if final answer, you can put it in this form. But if you're going to continue to do math on it, continue to work on it, you need to leave it in this form. Okay, really important subject coming up here. And that is dimensional analysis. Okay, so watch the video carefully on this, the lecture video. So what you're doing is you're converting what are called units of measure. A unit of measure is inches, feet, in this case yards, distance. It could be anything. It tells you what the number is referring to. 5.2. 5.2 what? 5.2 feet. So it tells you what it's referring to. 12. 12 what? 12 inches. It tells you what the number is referring to, okay? So this is called an equivalency. We know that there's 12 inches in 1 foot. You could also say there's 1 foot in 12 inches. So I'm going to write 2 conversion factors out of this. The way you would read this is there's 12 inches for every 1 foot. Or it's equally true to say that there's 1 foot for every 12 inches. Okay, those are both true statements. There's 12 inches for every 1 foot. There's 1 foot for every 12 inches. Those are both true statements. So these are both true. Now you may, at first you might look at this and say, wait a minute, I know in math, 12 over 1 is not the same as 1 over 12. The difference is you actually have units giving them the meaning. This is called a number. This, 12 inches, is called a value. So as long as you have a value relationship, 12 inches, 1 foot, you can do this. You can say this over this or this over this. In other words, you can't just simply say that 12 over 1 equals 1 over 12. We know that's not true. But as long as you have units attached to it, you can do that. All right, so what we're going to do is, the way you do these problems is you read the question, how many inches in 5.2 feet? So the first thing you always have to identify is, what is the question asking for? What are you trying to get to in the end of the problem? And the answer is some number of inches. So the way I like you to write this is equal sign, a place for your final answer, and the unit that you're looking for, inches. So always start off problems like that. Okay. Now what are we starting with? We're starting with 5.2 feet. So I'm going to start way over here. The reason I'm leaving so much space is because we're going to need a conversion, and sometimes you're not sure how many conversions you're going to need. All right, so I'm going to put 5.2 feet times, and now we need, and this box is just to give you kind of a worksheet, kind of a look to it. You're going to have to fill that in with one of these two conversion factors. Again, this is called an equivalency. These are called, I'll write it down, conversion factors. Okay, so which one of these two are you going to need here? Well, you need feet to disappear because it's not in your final answer. You need inches to appear because it is in your final answer. So which one of these two is going to make feet cancel out? Now that you know how to cancel numbers, and you know that you can cancel across a time sign, let's be very clear, that's a time sign there. That means if I have feet on the top, and if something is only on one level, you don't see a top and bottom here, but if it's only on one level, it's in the numerator, because remember, this is effectively over 1, right? So this is numerator, denominator, but you don't have to write over 1. So feet is in the numerator. That means we need feet in the denominator. We need it down here to cancel. So we're going to choose this one, the one that has feet in the denominator. So it's 12 inches for every 1 foot. Now notice we're not doing anything with numbers yet. We're simply going to cancel feet on the top and feet on the bottom. You cancel them just like they were a number. 2 over 2, 3 over 3, anything, it cancels. The only unit we now have left is inches, and that's not going to cancel because there's nothing to cancel it with, so that's got to end up in our final answer. I call this the last man standing. Okay, it ends up, it's the last unit you have that's uncanceled. That has to match up with the unit in your final answer. That's why you always want to put this down first so you can check, because if these two don't match, you did something wrong. You set the problem up incorrectly. Okay, so now we have 5.2 times 12. And that's going to give us 62.4 inches. Okay, and that's your final answer. All right, so study how you did that. Let's do another one. Now this one's a little more complicated. Okay, how many inches in 4.1 yards? So what we're trying to find is inches. Okay, so I'm going to write it across here, and then I'm going to write, we have two equivalencies here. We're going to need them, because over here we have inches, and over here we're starting with 4.1 yards. And we need to get to inches. How many inches? Now we don't have a relationship between yards and inches. We have a relationship between inches and feet, and between feet and yards. So we're going to need two conversions. So I want you to draw two boxes like this. And you leave a lot of space between these two because sometimes you don't know how many conversions it's going to take. Like that. Okay. So we've got 4 possible conversion factors we can write. I'm going to come down here and do that over here. We can say 12 inches, the same one we did above, for every 1 foot, or 1 foot for every 12 inches. Now this is going to kind of look busy, a lot of stuff going on here. We can take this one, the 3 feet equals a yard, come down here. There's 3 feet. 3 feet for every 1 yard, or 1 yard for every 3 feet. Okay, so look, you got all kinds of conversion factors. 1, 2, 3, 4. So how do you know which one to start with? You come over here, you have yards here. It's not going to appear in your final answer, so it has to cancel. Remember, these are going to be two ratios. These are going to be two conversion factors. There's only, you have yards on the top here. That means you're going to need yards on the bottom here to cancel. You need yards to cancel with yards. There's only one of these four that has that. Yards on the bottom. It's this one right here. So this is going to be our first conversion factor. 3 feet for every 1 yard. And this on top cancels with this on bottom. You need that to go away because it's not going to be in our final answer. Okay, now once you've used this one, you're not going to use this one. You're done with both of these. You're not going to use this one and this one. You're going to use one or the other. Now we're ready for our second conversion. We have feet on the top here. That means we need feet on the bottom here to cancel out because feet doesn't appear in our final answer. So that's got to be this one right here. It has feet on the bottom. So 12 inches for every 1 foot. So feet on the top cancels with feet on the bottom. And again, in this case, the last man standing is inches. It doesn't get canceled. There's nothing to cancel with. And that's what we need in our final answer. So we know that we set the problem up correctly. So notice we haven't done anything with numbers. We've just canceled units of measure so far. So now what you do is you multiply everything on the top. 4.1 times 3 times 12 divided by 1 divided by 1. So I'll show you that on the calculator. It's going to look like this. 4.1 times 3 times 12 divided by 1 divided by 1. And you hit equals, and that gives you 147.6. And that's your final answer. That's how many inches in 4.1 yards. Okay? All right, I want you to do this one on your own. It's the same concept, except now it's inches, feet, and feet miles. It's asking how many inches in 1 mile. Okay? And I want you to do that one on your own. I'll get you set up. We're trying to find some number of inches in 1 mile. So we come over here in 1 mi. Okay, we don't have a relationship between inches and miles, but you see two equivalencies. So you're going to need 2 boxes. Okay, so go ahead and write the 2 conversion factors for this, the 2 for this. That'll give you 4 in all. Figure out which one goes in this first box, which one goes in this second box, okay? Okay, I'm going to skip past these 2 for right now, and we're going to go on to the next page and learn about scientific notation. Convert the following decimal numbers to scientific notation. Okay, so this is just a regular decimal number. Sometimes you might put a comma there. In American numeric system, a comma is just to make it more readable. You put a comma every 3 digits to make a big number more readable. In some countries, that's treated like a decimal, not in the United States. So it doesn't really have to be there. So here's what you do. You write down the number, and you identify where the decimal point is. Now you don't see a decimal point there, but it's implied that it's right there at the end. That's where the decimal. You don't have any numbers after it, so you don't write it. What you want to do is move this so it's a number between 1 and 9.999. I can't say 10, 1.999. So where would you move this to be that? The answer is between the 2 and the 3. 2.34 would be a number between 1 and 9.99. So it's 1, 2, 3, 4. So it's 2.34. Can't cut off any digits except the zeros. You can cut those off. And you moved it 4 places. So it's times 10 to the 4th power. So that's scientific notation. Again, we use scientific notation to write really, really big numbers or really, really small numbers in a compact form. Okay, let's do this one. So we have this number. I'd like to rewrite it. I'd like to leave the original number on the problem set clean, so if you make a mistake, it's not all messed up. So where do we move this decimal so it's a number between 1 and 9.999? Okay, and the answer is between the 3 and the 2, 3.2. So you're going to move it 1, 2, 3, right there. So that's 3.2. That's a number between 1 and 9.99. And you moved it 3 positions. So the only question is it a positive or a negative 3? The answer is, since this number that you started with is less than 1, it's negative. So a negative exponent doesn't mean a negative number. If it were a negative number, it would have a minus sign out here, but it's not. It means that it's a positive number between 0 and 1. This is a positive number between 0 and 1, what we would call a decimal number. Okay, if it's greater than 1, then it has an exponent that's positive. So this is a number greater than 1. 23,400 is clearly greater than 1. Okay, so you go ahead and do the next 2. Okay, now we come down here. We're going to go in the other direction. We're going to go back to writing it in numeric or decimal form. So you take the coefficient. This is a coefficient, base, exponent. You write it here, 4.2. And now, first of all, just simply ask yourself, this is a positive exponent. This can be a number greater than 1 or a number less than, or a number between 0 and 1. It's going to clearly, or number less than 1 but positive, between 0 and 1. It's clearly going to be a number greater than 1. 10 to the third is 1,000. So that means which way do you move the decimal to make it a number bigger than 1? You need to move it to the right. 1, 2, 3, and put the decimal right there. So this is the egg carton, so you put the eggs in the egg carton like that. Now don't leave your answer like that. Just rewrite it properly. So it's 4,200. Okay, like that. Okay, let's come down here. Again, write the coefficient. All right, now this is a negative exponent. That means it's a number less than 1. Which way are you going to need to move this decimal to make it a number less than 1? Positive, but less than 1. You're going to need to move it to the left. 1, 2, 3. So the decimal goes there. Put eggs in the egg carton like that. And now rewrite it down below. Typically, you write a leading 0 in front of a decimal point. It doesn't change the value of the number. It's just the way it's usually done. In fact, I would say always done. So it's 0. Now write the rest of it here. 0, 0, 9, 8, 2. And that's your final answer for that question. Okay? So you do this one. Now this one might be a little tricky to you. You just start here and you move it back 6 places. So you start here and it's 1, 2, 3, 4, 5, 6. So go ahead and do that one. This one's just like this one over here. So go ahead and do that one. All right. Now we're going to do multiplication of scientific notation. And the rule for this is the coefficients you multiply, times sign. The exponents you add. So just go ahead and write those arrows like that, those lines, and those plus and times sign to keep it straight, okay? All right. So here we go. So 5.2 times 2.8 is going to give us, and you can just do this on your calculator. That's going to give us 14.56. And 5 plus negative 3 is the same as 5 minus 3, so that's 10. 5 minus 3 is 2 to the second. Okay, so that's your answer almost. But we said in the lecture video, the coefficient is supposed to be in scientific notation a number between 1 and 9.999. So in order to do that, we need to move this decimal over to here. So it's 1.456. That's a number between 1 and 9.999. Okay? All right, but you can't simply move a decimal like that. It changes the value of the number. So what you have to do is compensate by changing the exponent. So here's the simple way you reason it. We made this number smaller. 14.56 became 1.456. We made the coefficient smaller by 1 decimal place, so we have to make the exponent bigger by 1 number. So it raises it to 10 to the 3. So 14.56 times 10 to the 2 is equal to 1.456 times 10 to the 3. But standard scientific notation form is to have this number, the coefficient, be a number between 1 and 9.99. So we needed to make that decimal adjustment. Okay? All right, let's go ahead and multiply this one. down here, let's do this one over here. This one's actually kind of easy because you'll find you don't need to make the decimal adjustment here. Multiplying 0.2 times 6.1 will give you a number that is between 1 and 9.999. So let's do one more over here. It's 2.9 times 9.1. And that gives us 26.39 times 10. And I should have written that I multiplied these two right here. That's a times sign. And these two get added. Now be careful. I would write this down. Negative 2 plus negative 5 is equal to negative 2 minus 5. Now, students still get confused with that. So here's the way I look at it. Here's a number line. Here's 0. Negative 2 is over here somewhere. So you're starting at negative 2 and you're going in the negative direction 5 more places. So negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So that's going to equal negative 7. Okay, so it's 10 to the negative 7. Okay, so be careful with subtracting and adding negative numbers. Now we don't have a number between 1 and 9.99, so we're going to move the decimal one place over here and make this number smaller, 2.639. That means we've got to make this number bigger. Now be careful on that. If you got a negative number, to make it bigger means you go in the positive direction. So is it going to be negative 6 or negative 8? It's going to be negative 6. You're going in the positive direction. You're getting closer to 0 and away from negative numbers, okay? So this is your final answer there. Okay, let's keep going. Now we're going to do long division, and the rule for that is simply you divide this by this, divide these numbers, and then you're going to subtract. So that's a minus sign right there. 5 minus 2. So come on down here, do this on your calculator. 8.4 divided by 2.7 equals 3.1. You can round it to 1 or 2 places after the decimal. I'm not going to be particular. You'll learn how to do that. You'll learn rules of that later on. Okay, 3.1 times 5 minus 2 is 3. So times 10 to the third. And that's all there is to that. Okay? How about this one? We'll do this one. I'll leave this one for you. 3.2 divided by 6.4 is going to be 0.5 times 10. And be careful. This down here is negative 2 minus negative 7. Negative 2, there's a minus sign there, minus negative 7. Double negatives becomes a plus sign, so it's negative 2 plus 7. And you might even want to flip this around. If you understand, you got to be sure you take the sign with each of these. So I'm going to put the 7 over here and put the negative 2 over here. 7 minus 2, so that equals 5. Okay? Just be careful. Students make a lot of mistakes with negative signs, especially with division problems. So this is to the 5 power. Okay, but this is not a number between 1 and 9.99. So we're going to move the decimal over to here and make it 5. Now this time we made this number bigger. It went from 0.5 to 5. So we've got to make this number smaller to compensate for that. So it's 5 times 10 to the 4th, and that is your final answer. Okay? All right, let's keep going. All right, so this is in your reference packet, and these are some standard abbreviations you're going to see, meaning used for some very large and very small numbers. So let's start with this one. We never use tera almost. Giga. We use a billion. That's 1 billion. That's the number billion right there, 1 billion. It's 10 to the 9th power. It means 1 with 9 zeros. If you count, there's 9 zeros there. That's giga. It's abbreviated capital G. Mega is million. That's 10 to the 6th. That's 1 with 6 zeros. That's a million. Kilo, it's a lowercase k, 10 to the 3rd. That's 1,000. Okay, we never use hecto or deca. Deci is we never use. Centi we do use. 10 to the negative 2 power. That's 1/100th of a meter. It's called a centimeter. if it's a meter. It could be grams, it could be anything. So these are just prefixes that go in, these go after the word. Okay, milli is a small m. So if it's a meter, it's millimeter. Mm, it's 10 to the minus 3. It's 1/1000th of a meter. Micro is this little symbol right here. Greek letter mu. It's 10 to the minus 6. It's 1/1,000,000th of a meter or a gram. Nano is 1/1,000,000,000th right there. And pico is 1/1,000,000,000,000th right there. Okay, so let's do a couple of these. So all I want you to do is convert this into scientific notation. So it's 320. You just go ahead and write that number. Now you don't have to adjust the decimal in these, okay? And it's milligrams. There's milli right there, 10 to the minus 3. 10 to the minus 3. You still have to write the grams. This is substituted by this, but you still have to write the G. So it's 320 times 10 to the minus 3 grams. Let's do this one, 720 picometers. So it's going to be 720 times 10. We come up here, pico is 10 to the minus 12th. Okay, so the P is substituted by this, but you still have to write the M for meters, so it's meters. Okay. All right, and I'll do one more here. 101.5 megahertz is a radio station in San Diego called KGB that has this broadcast frequency. So that's going to be 101.5 times 10. It's capital M, mega, so we come up here. There it is. Mega is 10 to the 6th. 10 to the 6th. Okay, and that's hertz is a unit of frequency. We'll talk about that later in the course. So you write hertz, okay? I'll leave the other 4 for you to do. Okay, so you can do the others the same way. All right, let's go back. There was one problem that I kind of skipped over because we hadn't covered that concept right there. And it's this, this one down here. So it's how many micrometers, that's this. So we now know that that means 10 to the minus 6. Just go back to that table. Are in 2.2 meters. Okay, so we're trying to find micrometers, so we're going to come over here. Micrometers. Okay. And over here, we have 2.2 meters to start with. And we have a conversion that directly relates us micrometers to meters. So we only need one conversion, so I'm going to put one box. Again, sometimes you're not sure, so you just leave a whole lot of space in between those two. That's just empty space. Okay, and there it is. So we can make 2 conversion factors out of this. We'll write them over here. 1 million micrometers for every 1 meter, or... Okay, so which one of these two is going to go up here? You need meters to cancel out and micrometers to appear in your final answer. Probably should have made my box a little bigger, but I'll live with it. Okay, so we need meters to cancel out, so that means we need meters on the bottom here, so this cancels with this. That means the 1 million micrometers needs to go on top. Okay, so we have 2.2 times a million divided by 1, and I need to give myself a lot of space there, so I'm going to go ahead and write this 2,200,000. That's what you would get on your calculator, micrometers. So that's your answer for that question right there. Okay? All right, that takes care of this answers video. If you have questions on others, I have a lot of tutoring time. Come in, see me, or see me in class for further help on this.